A motherboard, also known as the main board or logic board, is the central hub of a computer system, acting as the backbone that connects and allows communication between all other components. It houses the CPU, GPU, RAM, and expansion slots, and provides the circuitry through which these components communicate. The motherboard includes a chipset that manages data flow between the processor, memory, and peripherals, and features a variety of connectors for additional components like sound cards and storage devices. It also contains the BIOS UEFI firmware that initializes and tests hardware components during the booting process, and offers interfaces for external connections like USB, HDMI, and network ports. Essentially, the motherboard is crucial for the integration and functionality of all the computer's hardware elements, ensuring they work together harmoniously. The Central Processing Unit, or so-called CPU, often referred to as the brain of the computer, is a critical component responsible for executing instructions from programs and performing the basic arithmetic, logic, control, and input-output operations specified by these instructions. It consists of several key parts, including the arithmetic logic unit, which performs mathematical and logical operations, the control unit, which directs all processor operations and manages the flow of data within the CPU, and various registers, which provide storage for immediate data and instructions. Modern CPUs typically feature multiple cores, allowing them to process multiple instructions simultaneously, significantly enhancing performance and multitasking capabilities. They are connected to other system components via high-speed interfaces such as the front-side bus or direct media interface, and often include integrated graphics processors for handling visual computations. The performance of a CPU is determined by its clock speed, measured in gigahertz, the number of cores, cache size, and the architecture's efficiency, all of which contribute to its ability to handle complex tasks quickly and efficiently. A graphics processing unit, GPU, is a specialized electronic circuit designed to accelerate the rendering of images, videos, and animations for display. Unlike the CPU, which handles a wide range of general-purpose tasks, the GPU is optimized for parallel processing, making it exceptionally efficient at handling complex calculations required for rendering graphics. GPUs come in two main forms: integrated, which are built into the CPU and share system memory, and dedicated, which are separate cards installed in expansion slots like PCIe and have their own VRAM, video memory. High-performance GPUs are essential for gaming, 3D rendering, video editing, and applications requiring heavy graphical computations like machine learning and scientific simulations. A hard disk drive, HDD, is a primary storage component in a computer used for storing the operating system, software applications, and user data such as documents, photos, and videos. It consists of one or more spinning disks called platters coated with magnetic material and a read-write head that moves across the platters to access or record data. HDDs are non-volatile storage, meaning they retain data even when the computer is powered off. The performance of an HDD is measured by its rotational speed, typically 5,400 or 7,200 RPM, revolutions per minute, and its data transfer rate. HDDs offer large storage capacities at a lower cost per gigabyte compared to solid-state drives, SSDs, making them ideal for extensive data storage. A solid-state drive, SSD, is a high-speed storage device used in computers to store the operating system, software applications, and data. Unlike traditional HDDs, SSDs have no moving parts, relying instead on NAND flash memory to store data, which makes them faster, more durable, and energy efficient. SSDs provide significantly quicker data access and boot times, improving overall system performance and responsiveness. The lack of mechanical components in SSDs reduces the risk of physical damage and failure, and they are virtually silent in operation. While SSDs are more expensive per gigabyte compared to HDDs, their benefits in speed, reliability, and power efficiency make them a preferred choice for modern laptops, desktops, and high-performance computing environments. Random access memory, RAM, is a crucial component in a computer, serving as its short-term memory, where data and instructions needed by the CPU for immediate processing are stored temporarily. Unlike long-term storage devices such as hard drives and SSDs, RAM is volatile, meaning it loses its data when the computer is turned off. RAM enables faster access to data compared to other storage types, significantly impacting the system's overall speed and performance. It consists of memory modules that fit into dedicated slots on the motherboard. motherboard. The size and speed of RAM, measured in gigabytes and megahertz respectively, determine how much data can be held and how quickly it can be accessed. Modern systems use DDR, double data rate RAM, with versions like DDR4 and DDR5 offering improved bandwidth and efficiency. Adequate and high-speed RAM allows for smoother multitasking, faster application loading times, and enhanced performance in memory-intensive tasks such as gaming, video editing, and large database management. The power supply unit, PSU, is a vital component of a computer, responsible for converting the alternating current, AC, from your home or office outlet into the direct current, DC, required by the computer's internal components. It distributes appropriate voltages to the motherboard, CPU, GPU, hard drives, SSDs, and other peripherals through various connectors and cables. PSUs are rated by their power output, measured in watts, W, with common ratings ranging from 300 watts to over 1,000 watts, depending on the power requirements of the system. A high-quality PSU ensures stable and reliable power delivery, which is crucial for the longevity and performance of the computer. It includes various protections such as overvoltage, undervoltage, overcurrent, and short-circuit protection to safeguard the components from electrical damage. Cooling systems in computers are essential components designed to manage the heat generated by the CPU, GPU, and other hardware to ensure optimal performance and prevent overheating. These systems include air cooling and liquid cooling solutions. Air cooling typically involves heat sinks attached to the CPU or GPU with thermal paste to enhance heat transfer, along with fans that dissipate the heat away from the components and out of the case. Liquid cooling systems, which are more effective but complex, use a pump to circulate coolant through tubes to a radiator, where fans then dissipate the heat. Effective cooling is crucial for maintaining system stability, extending hardware lifespan, and allowing for overclocking, where components run at higher speeds than specified by the manufacturer. The casing, also known as the computer case, chassis, or tower, is the enclosure that houses and protects all the internal components of a computer, such as the motherboard, CPU, GPU, RAM, storage devices, power supply unit, and cooling systems. It provides a structured and secure environment for these components, ensuring they are correctly mounted and adequately spaced to prevent overheating and physical damage. It features ports and connectors on the front and rear panels for easy access to USB, audio, and other interfaces. Additionally, the casing often includes mounting points for fans and radiators to support effective airflow and cooling. Available in various sizes, such as full tower, mid tower, and mini tower,